Right.
Here we go. We're live. Hey, what's up, everybody? Shall we get a? We'll actually just give a couple more minutes till everybody shows up. Here we go. We're live.
We're definitely live.
Yeah. Great. Yeah, Spider-Man. I love that game. Final Fantasy. Have you played Final Fantasy yet?
No, I haven't played Final Fantasy in years.
Yeah, the new Final Fantasy is really good. I haven't. I've been so into Spider-Man because Spider-Man's actually been in my collection for a couple of years, but I didn't actually start playing it until a couple months ago, and I couldn't believe how long I've just been kind of sleeping on it. But Final Fantasy is really good. That's the next one that I'm going to do after I finish all the Spider-Man extensions.
And yeah, that game is just mind blowing. It's like it also feels like so natural. Like I've had people come to my house and they never played the game, and you give them the controller and you're like start playing, and they immediately get sucked into it.
Yeah, and it's
because you feel like you're Spider-Man when you're playing it.
yeah, and what's yeah, it's crazy. No matter how long you're on the game, you discover moves that you've never actually done before as well.
Yes.
But yeah, cool. All right, it's 5 o'clock, so I guess we should get started. Hey, what's up, everybody? We're here live with our good friend Eyal Amir from Xfer. How's it going, Eyal?
Going good. How are you?
I'm great, and it's really exciting here on a Friday afternoon to talk about CMake and talk about JUCE and audio programming. It's a great time to be in audio development right now. And we had a discussion earlier today on the Discord. By the way, real quick announcement. If you want to get involved in audio development, or you want to talk with other audio developers or learn more about audio development, come join our community over at theaudioprogrammer.com/community. And we have developers of all different levels, meeting each other, helping each other with audio development, all different types of audio development as well, not just C++. So come join us, theaudioprogrammer.com/community. And how did that sound? Did I sound like a radio announcer there?
Yeah, but it sounds like a good radio announcement.
Yeah, I've had a couple of years of practice now. So we had this discussion earlier today with Ruben, who's from the JUCE team, and of course, JUCE 6, if you don't know, is going to officially support CMake. And there are a lot of people, including myself, that don't really know a lot about CMake and how to get into it. Why do I need to use it, and the basics around it. And Eyal is with us to show us around and start getting us into the hello world of CMake. So I'll step back and let you take it away, Eyal.
All right. So first of all, let's talk about why does something like CMake exist before we even talk about like how to use it and stuff. So when we're talking about, we're all C++ programmers, and the concept of a build in C++, especially a cross-platform build, is a very difficult one in general, and it has been for years. If you've ever used, something like like a JavaScript or Python or something, usually you have just a few source files and you just put them into a project or a library, and it's pretty easy to just get them to compile on any machine, pretty much. Like as long as you're using JavaScript and you have, I don't know, a Node environment or a React environment, basically you have what it takes. And usually there's a package manager and you have NPM or whatever tool is in Python. So it's pretty easy to just take some source files, get the thing to run. And there's not a lot of discussions about it, right? But it's not really the case in C and C++. A build is something very complicated, and to build on other types of machines is in its own, on its own, like a very elusive topic. I know a lot of experienced programmers who have no idea how to build their own code on a different platform. Like they have no idea how to even start.
Mm-hmm.
So let's explain why is this so complicated. So a C program or C++ program is not just some code. It's actually a bunch of uh, separately compiled units, which are basically like each CPP file. Each of those has been compiled by the compiler, and then it all comes together with something called the linker that takes it all together and makes your program or plugin or whatever it is that you have. But a big part of a program is not just your code, it's other people's code. It's libraries, maybe it's system libraries. Uh, so it could be all kinds of things that are happening in the build that needs to be described somehow to the computer. So if you've ever learned C++ and used C++, usually there's some sort of a build system you're already using without knowing about it. Like if you use Xcode, there's the Xcode system. If you're using Visual Studio, there's the Visual Studio build system. Linux has make files. There's all kinds of other build systems, but usually you have something like some project file where you open up Visual Studio, you load your CPP files, and then you click compile, and it kind of knows what to do.
Mm-hmm.
But that only works with that one system that you're using right now.
Okay.
You cannot take a Visual Studio project from Windows and build a Mac plugin or app or something. That's not possible. You can't take a make file in Linux and wait for it, kind of hope for it to compile in Mac. Just not going to work. And if you just import all the C files, that would only work if the project is really simple. Like you'll never be able to build an audio plugin by just grabbing the C files. Usually a build is really complex. Usually a build will be like different files will build for different platforms, different libraries. Maybe there's some steps that are happening in the build, like copying files from somewhere to some other place for this program to run.
Mm-hmm.
So this is a problem that many people try to solve in different ways. So many companies would just make their own build system. Like some companies would just write some Python script that the developers are running, and that script would just be like huge, if statements, right? If it's Windows, do this. If it's Mac, do this. If it's on an iPhone app, do something else. So there'll be like a big switching that kind of represents this code. And if you've been writing plugins or audio software, there's a great tool called the Projucer that does this. And the Projucer is also essentially a master build system. Yeah, you load some code files into it, and you pick a template, and you say you want a VST or audio unit plugin, and you give some properties to the thing. Like if it's an app, you might say that this thing needs microphone access, etc., etc. And the Projucer essentially is a program built by JUCE that's generating all the different build projects for you. Like it exports something for Xcode, something for Visual Studio, etc. And eventually you end up with something that you can build on your machine or on any machine. So that's good. But the Projucer only solves the problem for a very, very specific use case. It only solves the problem, first of all, if you're using JUCE. Second of all, it only solves the problem if you want to do things that the Projucer was designed to do. And we'll show some use cases soon for things the Projucer was not designed to do. So if you want that to happen in your build, like there's no way for you to make it happen unless you go and change the code for the Projucer, which is hard. Like it's a very complicated program because if you want to add some features to the Projucer, you're going to have to work on all the different if statements. If it's Linux, do this. If it's iOS, do this. Like it's very low level work. It's very hard, and unless you're an expert or something, it's very hard to do this. So that's where something like CMake came in. CMake has existed for quite a few years, but it's becoming very, very popular in the last few.
Mm-hmm.
And what it is a very simple language of sorts, very, very simple, much simpler than any, than Python or JavaScript or something. It's just a very simple language that can generate all the different build systems. Like so CMake internally knows about what it takes to build on Linux and what it takes to build in Visual Studio, and it can take what you describe for it, like in the Projucer, and just create a build for you.
Mhm.
So that's basically what it is. That's the problem it was trying to solve. And now, if you'll go to some libraries online, to just go on GitHub and look for libraries, look for Boost, look for SDL, look for almost any kind of library that's built in C and C++, almost all the popular libraries now switch to using that. Because it's a much more flexible system than all the different build system that existed before, and it's not specific for, there's no one system that's specific for Boost or something. It's the same system for JUCE, Boost, or if you want to use both of them, so you can just combine.
Okay.
It's just a general description of what it is.
I'm going to ask a question that I know some people must be thinking. So if you're working on Mac and you're using CMake, will you be able to build for Windows if you're building on a Mac machine using CMake?
So CMake is much dumber than this question, if you know what I mean.
Mm-hmm.
Like the answer, generally speaking, is no. Like you will not be able to write code, click build in a Mac, and have it build for Windows. Like you'll actually need a Windows machine with a Windows compiler.
Yeah.
But you will not have to be the person who's configuring that compiler, which you would be unless you have a cross-platform system.
Okay.
Right. So so for example, if you didn't have something like the Projucer, and I worked in companies that didn't have the Projucer or use JUCE. So some of what these companies did was, whenever you added a file, like I say I needed to add one more CPP file to my project, what I would need to do is go to the Mac computer, add that thing, click save, then boot the other Windows computer, drag the same file into Visual Studio, save that, and then commit the thing to Git.
Mm-hmm.
And if we have a Linux build, I'd also have to do the thing on a third machine, which is a Linux machine. Like you'd actually have to drag the file manually to each of those.
Mm-hmm.
If you need to add an include directory, you need to do it 3 times. So even if you don't even want to build, but somebody eventually will want to build on another machine, you will have to get another machine for this to work. Like it's quite hard.
What does that do when you so you say you have to manually drag it? What does it do that is so specific to that operating system?
Yeah. So so if you look at, like, let's now talk about something like Xcode, right? Xcode has, and I'm going to simplify this, right? But Xcode has a project file, which is essentially a data file, an XML or something like that. And it's got a bunch of data on how to build. Like it's got data on the source files, it's got data on build steps, if it needs to copy things, which libraries to link. And, if you open the settings, the build settings page in Xcode, there's a bunch of build settings of like which compiler flags you need and which compiler flags in debug and release. Like it's a very complicated page if you ever look at it. So the Xcode project basically has that. Like it just has tons of data, which it needs to generate the things for you.
Okay.
So but one of the stuff is the list of files, right? Like this one thing that's there. So you drag something there. What Xcode does is it saves that thing into some big file.
Mm-hmm.
And then when you click build, it knows to kind of gather all the list of files and send those to the compiler.
Yep.
But that thing is only specific to Xcode. It will never work in any other system. You can't go to Visual Studio Code and say, open the Xcode project. It's definitely not on Windows.
Yeah.
Especially if you use a different IDE and a different compiler. And like it's very specific to only that way of working. Not to mention, even in Xcode, you might have different settings for an iPhone app and a Mac app, right?
Mm-hmm.
And Xcode does not really know how to share these settings in a clean way. You're going to have to define what's shared and what's not shared.
Mm-hmm.
It's not very easy to do.
Yeah.
So basically that. So when I say that about CMake is basically it's basically just a language that describes what, like, for you, the user, what do you want to have happened, right? It just describes the build, and then you can make it export a build system that you want to use, like Xcode, for example. Like you can go, but because it's one layer above Xcode
Hmm.
in the hierarchy, it also knows about Windows or about iOS. Like you can translate it to anything without rewriting everything manually by hand.
Hmm. Okay, interesting.
Which is essentially what the Projucer is doing. Just to be clear, like the Projucer is that, but meant for a very limited scope of applications.
Yeah. Okay, great. Yeah, shall we take a look? Also, we have Ruben Thomas from the JUCE team that's joined us in the chat as well. So, hey, Ruben, he's been nice enough to join us. So, if you have CMake questions of any sort of complexity or situation, I imagine that Ruben will probably be able to answer your questions. So, feel free to ask if you're in the chat.
Yes. It's important to note that I'm not a CMake expert. Ruben is actually a real expert. He works for the JUCE team. He knows, he's very well versed in the world of CMake. He's been, I believe, the person in charge to do the new CMake integration in JUCE 6, which we'll talk about quite a lot.
Mm-hmm.
The reason why I'm talking here is because I'm interested in CMake for my own uses,
Mm-hmm.
right? I needed CMake for what we do at Xfer. I needed CMake for my own personal projects. I needed some features that it has, so I learned a bit about it, and I learned enough about it to maybe talk to you about it. But I'm not an expert, and I probably will need to mention this in many times throughout this video, because some things I just learned how to do by asking people like Ruben or Elaine Martin, who made Fruit, which is another CMake library for JUCE.
Mm-hmm.
So a lot of what I learned was just reading online or talking to them, just trying to figure out how to do things that I needed to do.
Yeah, and I think one thing that I'd like to emphasize as well is that you don't need to be an expert in order to use CMake, and that this is designed to show you that, hey, it's relatively straightforward to get into, and that's the reason why we have people like Elaine and Ruben and people like that to help make things easier for us to be able to use and do what we concentrate on doing, which is building products.
Exactly.
Yeah.
Exactly. And the reason why a lot of the C++ world outside of JUCE has moved to CMake is because for most things, you probably need to know just the very basics. Like you don't need to be, I mean, you might want to learn more if you're the person in charge of some complicated build system, but if you're just building, your app, your plugin, or even more than a few apps and plugins, you just need to know a few commands.
Yeah.
You don't need to know much more than that. Like it's not much of a learning curve other than using, or it's not so much. It's not so different from using the build system you're already using, like Xcode.
That's great. Cool. Shall we look at some code?
Yep. All right. So, can you see my screen here?
Yep. I can see you, can see myself.
Right. So I'm going to start my favorite IDE, which is CLion. I am going to show a bit later on how to translate everything I'm doing also to Xcode. We can also do a video later on Visual Studio and Windows tools. I just don't want to load too many tools at the same time. But one of the reasons why I like CLion is that, like a lot of modern IDEs, it has native CMake support. Some IDEs need a command that will translate from CMake to that IDE, but CLion does not. So it's like the translation is basically flat. Like you do something in CMake, it will build, and that's it.
Mm-hmm.
So I'm just going to start a new project in CLion, which will automatically generate. So let's call this like something like Hello World CMake. And the real, like the template that CLion provides when you're creating a new project is actually the hello world of CMake. Like it basically auto generates it. So let's see what happens. I'm creating a new project. It's gonna build it. It's loaded. And so what CMake generated for me, can you see this, the right side here of the left side, sorry, of my screen.
Yep.
So basically, CMake just generated, or CLion, sorry, generated two files. One is main.cpp, which is the code file you're seeing right now. Let's put it a bit larger. And the other thing is a file called CMake lists.txt, which is basically a CMake instruction file. That would be the equivalent of an Xcode project that you would normally see in a code base. So this code is quite obvious. I think most people who learn C++ have seen this kind of code, right? This is just hello world. Let's build it and see that we're actually getting hello world.
Mm-hmm.
Great. I type in my password to debug, and we got hello world.
Mm-hmm.
Perfect. Now let's see how do we describe the build of this project. So this is the CMake list that builds it. Okay, so there's 4 commands here, pretty much. The first one is requiring a version of CMake to run this,
Mm-hmm.
Because you're going to need some version of CMake installed, and you probably need one that supports the commands that you're going to be calling. So this specifies the version.
Mm-hmm.
You have the name of the project, right? In this case, it's Hello World CMake. You have the version of C++, the CMake CXX standard. So this is C++ 14. I could do 11 for C++ 11. I could do 17. It's possible that my compiler even supports 20. I haven't checked. But that's just the language specification. And this is really the most interesting command here. It's add executable. So this means that I want this program to be an executable that runs like an exe file. And this is the name of that target that's going to be created for this executable. And this is the names of sources, right? In this case, it's main.cpp.
Mm-hmm.
So this is like the simplest build you can do. Like it basically says, here's a file, build this into an executable. And this is good enough to be translated into any build system. I can use this file, and which I'm actually gonna try. So I'm actually gonna go to my terminal, and I'm gonna type I'm gonna actually type the CMake command so I can turn this into an Xcode project, for example.
Mm-hmm.
So what I'm gonna do is type CMake -G. This means generate.
Mm-hmm.
And then Xcode. And the other things I have to do is basically tell it the source directory. So where is the CMake list.txt file that it needs to convert? So it's going to be just right here where I am. And I need to create some build directory. The build directory is all the temporary files that are going to be created during the build.
Mm-hmm.
So I'm just going to call it build. Let's run it. It's going to take a second to check that I have everything it takes. I'm going to check my compiler, blah, blah, blah. And it finished. Now let's see what it generated for me. Let's go to this folder, Hello World CMake, and I have a build folder created by CMake. And I have an Xcode project in here. I can open it. And it's basically ready to go. Let's click build. Let's switch to this target. It's called Hello World CMake and build. And it ran. So that's basically all that I needed to do. Here we go, Hello World. Right. So that's how I took one thing from CMake and translate it into this other world. I could have also done, if I was on Windows, call the same command like CMake -G and do Visual Studio. And you can even specify like versions of your IDE. Like it has exporters for like Visual Studio 2017, 2019, 2015. It knows all the different IDEs and can generate the right project for whatever you need. So this is very useful if you have different developers you're working with, and they all have different versions or different development systems. If you describe your build correctly, they can build and run your program with no additional configuration.
Mm-hmm.
So this is the Hello World, right?
Yeah. So to summarize what you're saying, So CMake essentially, I think a lot of people that may have worked in JUCE before may just assume that when you pull down a JUCE project and you happen to be using C-Line instead of Xcode or Visual Studio, that just because the source files happen to be the same, that it will just automatically build for you.
Yes.
And that's not the case. That
Unfortunately.
and that the Projucer is actually doing work in the background to ensure that no matter what IDE that you're building in, that it will actually build correctly. So CMake does essentially the same thing. It will translate your source code so that you can use it in whatever IDE that you need to use it in. But it can also do more than that, can it? Yeah.
Yes, a lot more. So, but it is true that the Projucer for most simple project is the way to go. I personally think that the Projucer is an amazing tool, probably the best one I've seen of its kind for for the C++ world. So if you're just starting out, you're building a plugin or an app or something in JUCE, you probably want to use the Projucer just because this is a very clean, safe way to do things. It works. It's very well tested. There's absolutely no reason to not use it for, when you're just starting out. Like, it's so simple. It has a button that says open in Xcode, right? Or open in Visual Studio. It's got these like graphic helpers for whatever you need. So that part is great. It's fantastic. So I just want to say that it's not it's switching to another build system needs to come from a need, basically, from needing something else to be done.
Mm-hmm.
And I mean, the first thing is that many people don't want to just use JUCE for a JUCE app. Many people want to have JUCE built as a part of something else that they're doing. Like they have a project that they've done with other libraries, and they just want to use JUCE for the audio side, or they want to use JUCE for the graphics utilities that they have.
Mm-hmm.
Like, some people have different requirements, so that's where the complication in a build system starts to come to play.
Great.
So let's continue. First of all, let's see if there's interesting questions here, or interesting comments by Ruben or somebody who knows more than I do.
They're mostly C++ questions, so nothing related to CMake just yet.
Right. So Ruben is saying, and he's very right about it, says that the CMake list is very similar to the Juicer project, right? It's the CMake list basically becomes, when you're working in a CMake project, that becomes your master, right? That's your master file that you're editing. And if you want to make changes to the build, that's the file that you'll have to change, as every user of this file, every platform you're going to build on, will actually generate things for that system. Like, you don't have to. And that's basically very similar to how you work in the Projucer. Okay, so let's switch back to my screen. And let's start talking about more complicated projects, right? So first of all, I mean, I don't want to go forever on doing console applications. So I'm actually going to switch up to doing a JUCE project, which is more interesting to, I guess, people watching this channel.
Okay. I actually have another question while you're doing that. So CMake, is this something that you download? You have to install it? How do you actually kind of get into CMake?
Yeah, so that's a really good question. In some systems, like if you already have Visual Studio, or I think some of IDEs just install CMake,
mm-hmm.
even if you don't explicitly do something.
Mm-hmm.
If it's not installed by any chance, you can install it. Like on a Mac, if you have Brew, you can just type Brew install CMake. If you're using Homebrew, on Windows, you can just download it. Like, you go to CMake.org, I think, and you just click download, and you can download it if you happen to not have it. How do you know if you have it or not? By the way, you go to your command line or terminal or whatever it is you have, and you type CMake. And if you don't have it, then you'll see that it doesn't exist.
Yeah.
That's basically like on many cases it would just exist because a lot of tools just bring it with them when they're being installed.
So what's the command to see if you have CMake already?
CMake.
Okay.
That's the command. Just type CMake, and if you won't have it, then it will just say command not found or whatever it is your system says when you type an error. So you just install it. It comes with a GUI tool and a command line tool, basically.
Great.
So these are like the general ideas about CMake, but and CMake has other commands to describe common things in your build, like the list of sources, libraries you want to link, include directories if you have sources from different directories. And I'll actually show examples of those now when we switch to JUCE. So maybe I'll just stop for a second by saying, that JUCE did not have native CMake support up until very, very recently. And this is something that's actually coming out now for JUCE 6. So I was really hoping that JUCE will roll this feature out. I'm very happy about it. So it's something that is not in the official JUCE version from the website just yet, but it exists if you go to JUCE on GitHub and grab the JUCE 6 branch. I will now show an example on how to do this, but this is something that's pretty new, like just came out very recently. And it's in testing stages, but I've already set up just a few examples to how to bring up basic projects using JUCE 6 and CMake to show how to get started with it.
Great.
Okay. So back to business. So on my GitHub, I made a public repository. If I go to GitHub, I made a public repository called JUCE CMake repo prototype. We should probably kind of maybe copy the link somewhere. But if you just look up this thing, JUCE CMake repo prototype, or look up my name, Eyal Amir Music, you'll find it. It's one of the few public repos that I have. And this is a prototype just to show one way to have a CMake set up with JUCE. So it's not a library. It's not some magic thing. It's just saying, if you want to copy paste some parts of it to get set up quickly, maybe this will help you. This was my idea when I created this. So to use this, by the way, you don't actually need JUCE 6 installed. This repo is set up in a way where if you have it and you have CMake, it will get whatever it needs to run, including JUCE with the correct version. So you don't even need to install JUCE from anywhere to use this. Right. So what I'm going to do is I'm just going to clone this. I'm going to copy the address, and I can go to basically the command line and just type git clone. I'm using CLion. So CLion has a kind of load from GitHub thing, so I can just copy this, but this will essentially call git clone, which you can call. There's no git submodules on this. There's nothing complicated about the settings. This is like the most straightforward Git project you can set up.
Great.
So I'm just going to clone this, and this will take a couple of seconds. And when I load this in CLion, CLion will immediately start to configure this. And you see that this is doing something. There's a step now that says updating JUCE from Git here at the bottom. And this is a build step that I created. We're going to see in a second how I did it. It's just a couple of CMake commands. What I did was I added a step to my build process that before the IDE project is even built, I forced it to go to GitHub, grab JUCE from the right branch, and install it on my computer. And I just did it so there will be no install cost, so that I won't have to start explaining somebody or myself how to install JUCE. This will make sure that I have it installed. I can actually bring in any library I want. I can, if I'm using SDL or any kind of Boost library, I can just do that, bring the sources, have them installed, done. I don't need to think about how to install this. And that's all finished. And now I have a bunch of targets that I can build, right? Let's pick up something like the GUI app template. Let's just build it. And it immediately knows how to build, what to build. I didn't have to do anything to change this other than having a CMake supported IDE. This, by the way, will work as is using Visual Studio Code. If you have the CMake extension, this will work in Visual Studio, the 2019 that has CMake built in now. So it just built, which is really nice. Like usually, if I had used the Projucer, I would have to point the Projucer to where JUCE is. Mm-hmm. I did not have to do this here. This is done automatically by some custom steps that I've set up using CMake. So what's going on here? How did this work? What's happening? So this is my folder. It's got a bunch of different subfolders in it. And this is my CMake list file. This is basically describing the way this is built. And let's see if we can just read this and understand this. The first thing I'm doing is similar to our hello world. Is I'm just setting up the minimum version of CMake that's required to build this, and I have the name of the project, which is called JUCE CMake repo. Next thing, I'm including a CMake file with some common functions that I made. We'll see that file in a bit, and I'm using something called include, which is very similar to a C++ include. This just brings in some other text file that has other CMake commands. Now I'm calling basically the only function here that I wrote. It's called update from Git. So this is the command that's bringing JUCE from GitHub. Like you see that I'm actually specifying the JUCE address here. And I'm giving it a name. The name is JUCE. That's just a name that I decided to give this library, or maybe it's the real name of the library. And JUCE 6 is the Git branch, because I'm using the JUCE 6 branch. Next, I have a couple of build options, which I will explain in a second.
Yep, I got a question really quick.
Yes.
Where did you find the command update from Git? Where did you get that from?
So I wrote this command, and I will show you in a. Let me just go over to this file. I will actually show how I wrote this command. It's very simple.
Okay.
It's a CMake, just like it's really a language. Like you can actually write functions. So, for example, if you have something that you're doing in every project, like let's say every project you have is going to be using JUCE, instead of just typing a bunch of commands every time, you can just have one function that does it.
Okay.
So you can basically specify things that you're doing more than once and put them in a function.
Okay.
So these are a couple of options that I've added. These are options that allow you to build like the JUCE examples and the JUCE extras from the build. They're currently turned off. And these are, all these commands are called add subdirectory. And what they do is that they're basically adding another CMake list from that subdirectory. So for example, I have a directory called apps that also has a configuration file similar to this one. So I'm just adding that. And you can chain different projects this way. Like for example, I'm also doing add subdirectory to JUCE source directory. These little curly braces and the $sign are indicating that this is a variable. So I'm using a variable here because only after I'm grabbing JUCE from Git, this variable will know where JUCE is on your computer. Because it's possible that it will be in different places in different computers. So this gets filled dynamically by wherever the git command installed it. And from then on, the build process knows where JUCE is. So there's no problem to just add it. All right. So this is like the top outline of what's happening here. So you mentioned this command called update from git, right? How does it go? So let's see this command. This command is, by the way, in a file here called git functions, which I basically just wrote a couple of functions into to just simplify the process of repeating this if I need to. So here you can call, you can write macros or functions. Macros and functions are slightly different in CMake, but they're basically the same concept. Like they're basically like, like a function that we know from any language. A macro and a function are only different in the sense that a function has its own scope, and macro works on the scope that it was basically on the global scope. So if you have variables you want to set that are going to be set everywhere. For example, in this case, I'm setting up this JUCE source directory and all the JUCE variable of where JUCE is. So that way, in that case, I think at least that I need to use a macro. But that's basically the same thing, a macro and a function in terms of purpose. So these are just CMake commands. So these are just stuff that if you go and look on Google how to fetch something from Git, these are basically the commands. Like I made it a function because I wanted this to be generic. You don't have to write this as a function, but I found that bringing stuff from Git is something that I do quite often with all kinds of libraries. So I wanted to have a clean function that I can just call to say, give me that library and not worry about it any longer. So this calls just a few functions and doing, declaring which repository this is and grabbing the properties and then populating this, basically grabbing the thing from Git. And there's also a couple of messages. Messages is just like cout, right? This is just to print to the user that I'm updating. So this is like a custom, a way to do a custom function. But honestly, most people will probably not use custom functions, right? Most people probably don't care so much about custom functions. They just want to have a build going with existing functions. So let's go back to my top list thing. So I have the Git process, which I wanted to add. And then I'm adding all the different subdirectories. So I'm adding the JUCE folder, I'm adding the modules folder, and then the apps and the plugins folder. So each of those, like let's look at the apps subdirectory, for example. It has a few projects in it. Each one of those is a JUCE project. And in it, there's a CMake list that is very, very simple. All it does is adds 4 projects, just 4 different projects that exist under this tree. One of them is so for example, I have a console app test. Let's run the console app template. And it built, and this thing shows hello world. So let's look at how the console app is being built. All right, so this is the text file that defines a way to build a JUCE console application. So this is more complicated than building the hello world C++ application, because this also has JUCE. So in this console application, you can use JUCE files or JUCE events or all. I believe this also includes stuff like JUCE timer and other classes that you might want in your class that come from JUCE. So what am I doing here? I have the same boilerplate as before. I have the project and the version of the project right on top. Here I'm setting some variable because I just wanted to say that the target name, the name of this project is the same as the project name. But I can actually just manually type and say that the target name is console app. or something. In this particular case, I decided that it's going to be exactly the same as the project name. So I'm grabbing the variable, the CMake variable called project name, which is console app template, and setting this in the target. But I could just manually type this as well if I want to.
Mm-hmm.
So the next two statements are JUCE provided functions. So these are functions that you're getting if you're getting JUCE and you're importing JUCE into CMake, you will automatically have access to those functions. So all of the JUCE provided functions, I believe, start with a JUCE underscore. So you know that they come from JUCE. If you look for them, they're in a file called, I think, juiceutils.cmake. So this is a file that comes inside the repository. There's really good documentation in the JUCE repo if you read it, so, which explains the names of the functions. But in this case, there's just a few that you have to know. So this is called JUCE add console app, where it says, give me an app with this name, right? The name is the same target name, which is the name of the project, which is console app templates. So I'm just using the same variable for the name. And here I'm given the product name, which is the name that will show up in the, on the window and stuff like that.
Mm.
So this will generate an app for me with the correct settings for a console app based on JUCE. The other command is JUCE generate JUCE header. If you've used JUCE, you're familiar with juiceheader.h.
Yep.
So juiceheader.h is an auto-generated file that the Projucer used to generate for you. This is doing a similar action, right? This is just generates that H file for you so you can include it. The other three commands here are just standard CMake commands. One is the target sources. So this just has main CPP, but if I had other CPPs, I would just add them right here. These are the compile definitions. So these are all kinds of definitions that JUCE might want. Like here, I'm turning off web browser and curl, which are just default JUCE settings. There's all kinds of different settings that you might want to enable, like build flags and stuff. Most times you might not want to touch this at all. And this is where you're specifying which libraries you want to link. So here I'm linking with four libraries. 3 of those are just special libraries that JUCE made so that I will have all the recommended warning, LTO, there's a link time optimization, and config flags. So these are basically flags. They're basically libraries that JUCE set up that will just configure all kinds of flags for me, so that I won't have to do those. This is very similar this is very, very much like using a Projucer template, right?
Mm-hmm.
Projucer template already fills out some things for you. So this basically does this under the hood. And here I'm specifying that I want to link with JUCE core, which are the core libraries. If I wanted to build an audio application, I might want to do something like JUCE audio utils, which is the JUCE audio library.
Mm-hmm. So one thing that I'll mention from Ruben from the JUCE team mentioned is that the generate header command is mostly for backwards compatibility with old Projucer projects, and that in newer projects he would advise against using it as the resulting designs are cleaner.
Yes, and he's right about that. I just don't want to start going over everything, but he's right. Like this is something that now there are now more modern ways on structuring your project without it. The reason I'm showing, I like showing this is because a lot of people are already familiar and have other projects that use JUCE header.
Mm-hmm.
So this is needed to support, let's say you ported a JUCE console app into this, you would have to have this command for the project to work.
Okay.
So it's quite important.
Great.
This is otherwise confusing because some people, like I know that I ported a lot of old projects into CMake when it came out. So this is something that I needed to know, because otherwise you get weird error messages that you can't tell. where they come from.
Mm-hmm.
But he's right. That is there probably should be, as time moves along and CMake is more widely adopted, I hope there will be less need on having this command at all.
Great.
Okay, so this is the example of like a very, very simple application, right? And if I wanted to add files to this application, let's say now I have this main CPP file, right? This is, by the way, my main JUCE, the entire code for the JUCE application.
Yeah.
The logger that writes the log. Like, let's say that I wanted to add another CPP file in here. Like, let's say I wanted to do something like, let's have another, header and source files. Let's call them something like my class, right? So if I build a class here, and maybe I wanted to move this function into, or create a function in another piece of code, right? Like whatever, something like void do something, and then maybe have something like this. Right? So let's say that I wanted to have this function called and run from my main CPP. I would need to tell the project that this file is a part of the build. So I would need to go to CMake list.txt and say that just like I have main.cpp file, I also have the myclass.cpp file in the build.
Mm-hmm.
You don't have to specify header files, by the way, because header files are not really a part of the build. Header files are usually included by the CPP files. So if I'm building myclass.cpp, and you see there's a function here, and so usually myclass.cpp would include myclass.h.
Mm-hmm.
So basically, I don't need to tell the build system myclass.h exists. The code for myclass.h would get brought up regardless.
Nice.
So now that I've done this, let's go to main.cpp, and maybe I will include myclass.h, and maybe I will do this function called, what was that function? How did I call it? So I had a class called myClass, and it has a function called do something. So now I can create this myClass class of type C and do C do something.
Mm-hmm.
And now, because I've informed the build system of this, this should build and call hello world and doing something here.
Mm-hmm.
So, and just like we've done before, if I will go now and call the CMake terminal command here, I can generate this project for each individual build system that any developer is running on.
Mm-hmm.
Let's look at something more complicated. Let's look at the GUI app templates. So the GUI app templates looks like this. There's a few more things, but it's essentially the same. Mm-hmm. So instead of doing a JUCE add console app, I'm doing a JUCE add GUI app, which is pretty much the same, just with a different function name.
Mm-hmm.
I'm calling JUCE generate JUCE header again. And here I have a few more files. Here I have the main.cpp file, I have main component, and I have main window. So these are the different CPP files that my source file is including. So let's build those. And here's this GUI app example. Mm-hmm. If you look at the code is not very interesting. All it is a main component that has a label that I customized, inheriting from label and adding the text hello world. Mm-hmm. Justified to center with a font with the size of 20. And this is really pretty much the JUCE regular template. This is very similar to the Projucer.
Mm-hmm.
I've modified this very slightly to fit my liking, but these are just templates. Really.
Yeah.
This is the I added those to my repository because many times I like to start with a template. I like to start by copy pasting, template of a GUI app type, and just start banging out, components and graphic objects.
Mm-hmm.
So you can literally copy paste this, including the CMake file, change the name, right? Like for example, if I wanted to add another app, I can just copy paste this to, let's call it special GUI app, right?
Mm-hmm.
Asking if I want to add this to Git. I will not add this to Git. I want to commit this special thing. In the apps subdirectory, I will add this directory, so it will get added to the build. It's called special GUI app. And I will change the name. Let's call this special GUI app. And once I got this, and I refresh the project, basically, if I was on Xcode or something, I would just have to run the CMake command again. This would refresh the project for me, just like a resave in the Projucer.
Mm-hmm.
And now I should have a special GUI app here under my targets that can be built and run, and I can just keep going and work with my new great app.
Nice.
Yeah.
So we have a question from Tim.
Mm-hmm.
Do you have any tips for linking libraries with CMake? And is linking a pre-built library any different?
Yeah. So there's a few ways to link different libraries. First of all, you can just link libraries using target link libraries. If it's pre-built, you can literally just put the name here. You might need to specify the directory of that library. Like there's also something called, Ruben can correct me, I think it's called target link directories. So you have a command where you're saying, here are the directories to search for those libraries. Like you can just add those. So I believe the syntax, I'm not 100% sure, is something like this, like the name of the target.
Mm-hmm.
In this case, this could have been special GUI app or the variable name. And then I could just say something like, this is going to be under CMake current list dir, like under this project / libs, right? For example, if you have libs, the libs target here,
Mm-hmm.
and then once you do this, you can just write the name of the library right here.
Mm-hmm.
Right, whatever. You can do something like SDL2 if that library exists there. You can just do that.
Okay.
It's very, very simple. You don't even have to worry about if this is a .lib file for Windows or .a file for Mac. You don't worry about this. You just write the name of the library.
Okay. Nice.
Yeah, it's very, very simple to bring in libraries into CMake. It's usually a very straightforward process. Any other questions before I keep going?
Yeah, and I see you saw Ruben's top comment just there. You can use.
Yes, and everything Ruben is saying is very important stuff. He's basically saying that there are indeed other ways you can do this. You can use the CMake has commands to do like something like find package.
Uh-huh.
So there's it's ways to bring in packages or to look for them on your computer, and there are also ways to kind of tell the user, for example, the programmer, if the package is not found. Like you can say, if the package is not found, like show an error message to the programmer saying, hey, you need to install whatever libraries you're missing. Like it's very good because it helps the programmer know what they're missing if it's not an automated process like I have here.
Nice.
Yeah. So let's show something cooler. Let's go talk about a plugin.
Great.
Right. So, I've made a template for a plugin here. This is really just the JUCE plugin template. let's have a look at it. So let's build it. Let's build a standalone plugin, for example.
Mm-hmm.
See that it's building and there's no build errors first. So a plugin, very much like a JUCE app, has a JUCE add function. So just like we had JUCE add, JUCE add GUI app, JUCE add console app, we also had JUCE add plugin. The JUCE add plugin is a bit more complicated because it has all kind of plugin characteristics, and this is similar to the plugin options we have in the Projucer window.
Mm-hmm.
So you can see here that there's all kinds of settings, like the name, the company name for the plugin.
Yeah.
This is important stuff. Is this plugin a synth? Needs MIDI input, needs MIDI output, is MIDI effect, copy plugin after build, right?
Yeah.
Stuff like that. The plugin manufacturer code, really important if you want to, test and distribute your plugin.
Mm-hmm.
And the formats, right? Here you have AU, VST3, and standalone. If you have those libraries, you can also add AAX. If you have a license, you can also add, VST2. But these are really just the options you need. Other than that, it's all pretty much the same. Like it's all pretty similar. I have the target sources, the processor, the editor, and every other custom source files you might add. And then I'm linking against JUCE audio utils, right? I talked to you before that JUCE core is usually for just the basics of JUCE. Audio utils is if you want all the audio functionality.
Mm-hmm.
So I'm adding this as well as all the JUCE recommended flags. And this will basically work as is, right? You can see that here in CLion, I have all the targets. I have the VST3. I have the AU target. I can just click it and go and start debugging in Logic or something. This should pretty much work as much as you're used to.
Mm-hmm.
Now I have another situation here, which is if you have shared code in different projects. So let's say I have functions that I wrote that I want to use in many of my plugins. This is a very common issue. Once you have more than one plugin, you kind of get sick of writing the same functions over and over again.
Mm-hmm.
It's not very useful to copy paste things all over the place because then your code is becoming unmaintainable. So there are all kinds of ways you can share code. So one of the ways in JUCE is to use something called a JUCE module. I believe you had a tutorial about JUCE modules on the channel, right?
That's correct. Yeah. Our friend Matt Cat Music gave that tutorial.
There you go. So I don't want to go too much about JUCE modules as it's explained in that other one, but essentially it's code that you might want to share. So here I've shown an example in my repository of I just made a module so that people can just copy paste this example module and do their own.
Mm-hmm.
But essentially, a module is just a collection of headers and CPP files. So, for example, I wanted to show an example of a white noise oscillator that I wrote, and I wanted to see how I can fetch it from my shared library instead of writing it into every single product, because I might have many products that need white noise.
Mm-hmm.
So here, what I did was I have a modules subfolder, just like I have. Let's go back to my top CMake list, the top folder. So just like I have apps and plugins, I also have modules.
Mm-hmm.
It's basically just a folder of shared code.
Mm-hmm.
So here I have in my modules folder, I have a CMake list.txt, like I have in any folder. And here I'm calling a function called JUCE add modules. This is very much like a JUCE add console app.
Mm-hmm.
I believe there's also a JUCE add module with one, and you can call this with multiple modules.
Mm-hmm.
It's possible that I have redundant calls here, but essentially I'm just adding the different modules that I have. And a module, let's go look at this shared processing code module. A module has some declarations. I'm sure Matt Cat covered this in his video, so I won't go too much into the module header stuff. But really, I'm just including two things. One is JUCE audio utils, which is the JUCE audio utils library, and I'm also declaring this as a dependency. This is actually important because this will signal both the Projucer or CMake, whatever it is that I'm using to create the project, which other libraries are needed to link against this. And the other thing that I'm doing is including white noise.h, which is my header file that has this white noise oscillator class.
Yeah.
Same thing with my CPP file. It just includes the header file that goes along with it and the one CPP called white noise CPP that has the interesting parts, the implementations of the three functions that this oscillator has. This oscillator, by the way, is not very interesting, and it's probably not the best oscillator. This was just like something I wrote in 10 seconds so I can have any kind of oscillator to show for. So let's see how is this used. So I have an example here called shared. Sorry, I have an example here in my plugins called plugin with custom module. Very original name. Let's look at the source code for this. The source code this is just basically a basic plugin processor code. And what I'm doing is I'm just adding this class that I have called white noise oscillator. I'm adding an instance of this class in my plugin processor. And in my plugin processor CPP, all I'm doing this has any kind of content is calling white noise.process. This is the only important function in this class. And first of all, let's run this and see if what I've done is going to be working. Hopefully the speakers will not go insane. Let's set up my output. Here we go. Oops, this was too loud. All right. You hear that?
Yeah.
Here we go. Incredible sound. Sorry about that. Was this too loud?
That was very loud. That was very loud.
I'm sorry. I'm so sorry about that.
It's okay.
I did not mean this to be loud. Hopefully, I didn't ruin the ears of everybody on this channel. I know. Anyway, so my idea was I wanted to create this so that I don't want to rewrite white noise every time. Like I want to have access to this white noise. I might make 50 synthesizers. I don't want to redo my work. So now that I have this, so let's see how this is set up in my CMake list.txt file. This is going to be pretty much identical to the previous plugin CMake list file. But now, instead of linking into the JUCE audio utils, I'm linking against my own shared processing code. And that module already knows to bring in its dependencies. So this module already knows to bring in JUCE along with it. So I don't need to specify the JUCE libraries that I'm working against.
That's pretty cool.
Yeah, so this is like a very simple way when you're starting to build on a repo, you're adding projects. This is like my very straightforward way to recycle code, to reuse code. Any questions before I move on to something even cooler?
Yeah, so I'm not sure if you're covering this later, but there was a question about adding binary data. So we had talked about the binary builder and images and outside assets. Yes. So how do you do that?
Okay, so this will probably be the last example I'll show because I feel like I've been talking for a while. But so in the repo, I have let me show you this example first, and then we'll analyze how this works. So I have this folder here, and this folder has it's called automatic binary data, and it has a couple of images under it. One looks like this, and the other looks like this. You can see that I'm very, very creative with my graphic design today.
Yep.
You really should not be looking at my graphic design tutorials. So what I've done, I've created a CMake project, and this is really like, for example, a feature that you can use that will exist in CMake but will not exist if you're using like the Projucer. So many, like for example, when I'm working, I'm adding a lot of binary data files like images, XML files, all kinds of, maybe wave files. Like I'll have all kinds of resources that I'm adding to the build. And when I was using the Projucer, I had to drag those manually, right? You had to drag them into the Projucer, resave in the Projucer, and then rebuild your project. And it's very easy to forget some of these steps, right? So you sometimes work with, you change the images list or something and you forget to add it or you forget to remove it. And things don't work as you want to. So let's have a look at this template project and what it does. So I'm just finishing to build this.
Yep. While he's finishing, just another reminder, if you have questions or if you are looking to get started in CMake or just want to hang out with other audio developers, be sure to join us on theaudioprogrammer.com/community. And that will link us to the Discord where you can connect with us and we can help each other out.
So check out something cool. This is the app, by the way. The app shows both images kind of one above the other. And let's say that I wanted this app to automatically show the list of images in my binary data, right? Let's say that I might want to, I don't want to code every image that I'm adding to my binary data. I want to go back, save the Projucer, save the project, type this, go to the code, change that. Like I don't want to do all this boilerplate where all I want to do is add an image. So let me show what this code does. So let's find another image. Maybe I will just print screen this part of the screen where we're talking.
Yeah.
So I'm just gonna I just made a screenshot of us. Should appear in my desktop. Here it is. Let me change the name to the audio programmer. Okay. And now I'm just going to copy paste, like literally, I'm just going to copy this into the images folder. Copied.
Yep.
Git. Done. Now, let me rebuild this project. I might need to do a clean build for this to work. Yes. I will need to first clean or just rebuild, basically. So I need to clean and then build again. And other than doing the clean, you will now notice that the build actually managed to follow that this folder has changed. And the code managed to follow that this has changed. Let's look at the new code that I just built. Here it is. Oh, didn't happen. Sorry. Didn't happen because I forgot to, I need to clean the entire, I need to clean this images, the images target and not the actual target. I was not paying attention.
If anybody has any CMake questions, feel free to ask in the chat, by the way. We have Ruben from the JUCE team joining us that can answer any CMake question. And big shout out to Daniel. Daniel's from Fully Finest Audio has joined us as well.
Let's rebuild.
And so normally would you be doing this in the command line then?
Yeah.
Yeah.
I think I just made a mistake. What was the mistake I made? Let me just see. Something stupid here. Let's see, my magical example did not work as I planned because I need to do this. You just rebuild, right? Might just need to rebuild. But anyway, the point I was going to say is that, well, I'm just this. Okay, so what I was going to say is that what I have here is I have a CMake file that that keeps track of that folder. Like it knows to keep track of that folder and just add whatever is there to build whenever I rebuild the project. Perhaps I just needed to reload the project. That's probably what I forgot to do. Let's see. Oh, right. Sorry. That's what I forgot to do. I need to click rebuild here. Yes, that should work. Here you go. Yes, that's perfect. Okay, so basically, what I forget to do is if I was using the command line, I just needed to call the CMake command again. That's the only thing I forgot to do, which is when I click here, CMake reload, it's basically just calling the CMake command again. Like this is just a shortcut for that. And here I have our image already in code. So I didn't change any of my code. I just added the image. This was the only change that I've made. I didn't have to change either the code or the CMake project.
Nice.
And this is one of the cool stuff so that you can do in CMake is you can have it automatically search for stuff and prepare stuff for you.
Nice.
So for example, I wrote a function here. Let's look at my CMake file is very, very similar to the GUI app CMake file. But what I also added a custom function. So this is a function that does something called globbing. So this is just goes through a directory, and it actually will also go through the subdirectories because it's a glob recurse command, and it's adding anything with the extension of JPEG like this, and PNG into a variable. After it's finishing this, if it had any images, you see, if not images, string equal to nothing. Basically, it asks if there are any images. Then it creates a target called whatever name the plugin is with images. It uses a JUCE function called JUCE 8 binary data that adds the file, and then it does target link libraries. Basically, links together the images with the binary data into my plugin.
Great.
And later on, I just call my function. So I say, add images from directory. This is my function to the target name. In this case, the target name is the same as my, is the same as my project name, right? Which is automatic binary data. And it searches this. Let's try this with another image now that I'm not blacking out. So let's have another screen capture. Amazing screen capture. I'm going to screen capture, for example, my mixer. So here is my amazing RME mixer being screen captured. Let's see this image being added. Here it is. Let's call it mixer. And I'm going to copy it into the images folder. Call the CMake command. This is what I forgot to do before. Just type CMake again. And now the build should keep track of what has changed, and everything is working.
Great.
I'm actually going to show how this works in code too. Like how does here it is. So in my code, in the C++ code, what I did was I called a function that did something called get binary data assets that loops over everything that's in binary data and pushes it into a vector. So I have a vector of some struct that has all the information of the binary data, which is in this case, the data and the size. And later in my main component, I have a vector of unique pointer of image component, which is a JUCE built-in component, a very useful one. And in my constructor, I am grabbing that vector, get binary data images. So whatever is going to be there during the build will get built and added. So my code will not have to change if I'm adding any more images.
Nice.
I can have 50 images and the list will show up. This is actually really useful, for example, if you have WAV files. Like if you have a list of WAV files and you want to just populate that list from whatever you had, like let's say you had a plugin that has samples, for example, like a sampler, you might want to use something like this to just populate that list of samples that you've decided to ship in your binary data. And that way you can change this folder without any code changes and any build changes at all.
Wow.
So this is something cool that cannot be done in the, with the Projucer.
That's really cool. So Ruben said, I think if you add configure depends to the global command, you can avoid the manual reconfigure step.
Right. Yes. I mean, again, as I've said from the beginning, he's right. I probably should show some more tips on how to do this. There are probably much more efficient and better ways to do everything that I've been showing. These are just like very practical examples that I'm making from my own use at my work with Xfer or at my work at home. So it's not necessarily like the most like efficient, list words for a CMake project. Hopefully you get the idea. Like that, the idea is that once you define your build in kind of like you define code with what's shared between project, what's going to be common to everything that you do. Because if you have things that are repeating actions, you can just write functions in CMake for those. Or have variables for things that are set. Like just to give you an example, if you have 50 plugins and they're all from the same manufacturer, right? You have a manufacturer name, you don't have to type it all the time. You can just use a variable so that, let's say your company name changes, or you decide that, your company name in a plugin should show, instead of showing, maybe instead of showing Xfer, it should show Xfer Records. So you just change a variable name and that's it. It will change everything in the hierarchy of plugins. You don't have to go through each and every plugin and make sure that it's changed.
That's right.
Same for if you decided that all your plugins should now be linked, or maybe have an include directory for new shared code that you decided to add. No problem. Just add it to the same place and all the plugins will have it.
Nice.
So you have all this power of controlling your build. Other people do things like have a post build step that does things like you can have post build steps that maybe signs that does code sign to your code. Something CMake. You can have unit tests integrated into your code. Like there's all kinds of other things you can now do without depending on the Projucer or your build system having that option.
Great.
Yeah.
So we have a question from Michael. Is this your modular framework? Not sure if I understand that question.
Is this my modular framework?
Yeah.
No, this is not a modular framework. This is just maybe we should say for people who just joined. So this is a public repository that I have on GitHub. If you go on to Eyal Amir GitHub, maybe I should I'm just gonna type this into the chat.
Yeah, great.
Yeah. So yes, it's true. I am working on all kinds of like things internally that I'm doing for my own projects or for Xfer. Like I have all kinds of like libraries that I'm writing for me or for work.
Yeah. So I guess that I should mention that as Eyal has said earlier in this tutorial, if you might have missed it, that for most people, the Projucer is probably the way to go in terms of what you need to do. This is more for people that may have larger code bases where you have a number of plugins that you're building across or that you need to build, or you have shared code where some people are using Visual Studio, but other people are using Xcode. And you have other libraries that you want to use, and JUCE isn't necessarily at the center of what you're building. These are use cases for using CMake rather than using the Projucer. But if you're typically just building your app in JUCE and JUCE is at the very center of what you're looking to do, then the Projucer will be able to serve most of your needs. So,
Yes, exactly. So exactly. So this is I mean, obviously this is an advanced way of setting up, but it also adds a lot of options because, for example, if you want to code with something that isn't supported by the producer, like Visual Studio Code or something, this is the way to do it. There's no you can just automatically start coding in JUCE and Visual Studio Code without it.
yeah.
Same for other kinds of IDEs. Like now, if you want to use something like Qt Creator, or so basically now almost every IDE is either supporting CMake natively or there's an exporter for it, and by using CMake -G, whatever your IDE name is. So it also opens up a lot of options for developers who are used to working in a different environment, right?
Yep.
I know that, for example, CLion, I mean, JUCE does have a CLion exporter that exists, but it didn't have all the functionality that the Xcode exporter had. So what I did for a long time was edit on CLion, but then switch to Xcode just to get a very stable build. Right? Because and I'm guessing that's just because it's very hard for the JUCE team to always keep track on the latest IDEs and the different functions needed to have a build. But with CMake, it's actually very simple. It's very simple to say, here's how JUCE will build correctly on all platforms, and JUCE doesn't have to maintain every IDE problem, just like the past.
Yeah, that's really interesting. Mark says thanks for the contribution to the live stream that we did a few weeks ago, and that was a lot of fun as well.
Awesome.
Yeah, great.
You have contributed somehow.
Absolutely.
Any other questions from anybody in the chat? I'm happy to answer.
Seems like everybody's satisfied and ready to go off into the world of CMake.
Great.
And yeah, I'd like to check it out as well very soon. And yeah, I think this seems like a natural place for us to wrap up. So this will actually be available online after we're finished as well. So if you're like me and forget quite easily, then you can go back and you can review and you can watch it in double time or half time and get it. Just keep repeating it until you get it. And always, like I said before, feel free if you get lost to put a comment in the comments or to join us on the Discord, and we will be able to help you out. But thank you.
Yeah. And if you just add for if you're actually pulling through or going through with working with CMake, definitely read the documentation that JUCE has provided in the JUCE 6 branch. That documentation is better than any explanation that I can do. I'm not an expert. Like I just have one way of doing things that kind of worked. But it's much better to just read the documentation or maybe talk to people like Ruben or others in Discord, in the JUCE forum. I mean, hopefully my examples will be like a bridge for people who have no idea how to even start, to just start. Like you just grab the repo, load it, or type the command, and that's it. But there's like, if you want to dive deeper into it, there's better knowledge than my examples for sure.
Yeah. And also another great resource, of course, for JUCE questions is the JUCE forum, and it's a great resource, especially if you're looking for a specific, if you have a specific problem, even outside of CMake, and you need to search for how to do something. Let's say you want to learn how to create a delay and you have no idea where to get started. JUCE forum is a great resource where you can just go hit the search function, type JUCE delay, and somebody will likely have asked the question that you're wondering about. So, so thank you very much, and thank you very much for Ruben for joining us as well in the live chat. Thanks for contributing your time, and we will continue on this discussion as well. I think at some point I'm going to maybe do Hello World from scratch with CMake, and maybe that'll help people along as well. So yes, we'll wrap up here. Thank you again, Eyal, for your time, and we will see you again soon.
Right. Bye.